11 students. Last topic was I discussed black body radiation, which is not been explained by the electromagnetic theory of radiation, and also another phenomenon, that is photoelectric effect, is also not explained by that electromagnetic theory of radiation. What is that photoelectric effect? When evaporated tube, glass tube, two electrode is taken. One electrode from where the electrons is emitted is taken as negative terminal, and another plate is taken as positive terminal. When light falls on this negative terminal metal, immediately the electricity is going to pass, that the electron ejected from this metal towards the positive terminal. This phenomenon is known as photoelectric effect. Now, this effect cannot be explained by the theory of electromagnetic radiation. Now, why the metal start ejecting electron after falling of light? There are few features of photoelectric effect. The features are: number one, the electrons are ejected from the metal surface as soon as beam of light strikes the surface. That is, there is no time lag. As soon as the light falls on the metal surface, the electrons start ejecting from the metal surface. For each metal, certain minimum frequency of light is required to eject electron. That means different metal require different energy light and different frequencies light. This is not that the sodium metal, whatever the frequency of light required for the sodium metal, it is not same for the cesium metal. So for the different metals, some minimum frequency light is required for ejection of the electron. And the third is, the kinetic energy of the ejected electron is directly proportional to the frequency of incident radiation and independent of intensity. Whatever the kinetic energy of the ejected electron is dependent upon the frequency directly. Wherever the frequency is high, the kinetic energy of the ejected electron will be high. It is not dependent upon the intensity of the light. The intensity of the light is proportional to the number of electrons ejected. If the intensity of the light is high, the number of electrons ejected will be more. But the intensity of light not related to the kinetic energy of the ejected electrons. I am just drawing some. Next is, for each metal, certain minimum frequency light is required to eject electron. Minimum frequency of light is required threshold frequency. If we plot a kinetic energy versus frequency of light diagram, we can see that at minimum frequency is required to eject. After that more frequency, the kinetic energy of ejected electron will increase. And if we draw kinetic energy versus intensity, it will be a constant. Whatever the intensity of light, it's a constant. So how can we explain this phenomenon? Now, to explain this phenomenon, we have to come Planck's quantum theory of radiation. Now, the classical cannot explain this because according to that theory, the radiation is always continuous one. But that theory is not enough to explain black body radiation or photoelectric effect. Now, what is Planck theory of quantum radiation? First, that radiant energy is not emitted or absorbed continuously but discontinuously in the form of small packet of energy called quanta. Each quantum is associated with a definite amount of energy. That means the energy, whatever anything emitted from or absorbed from anything, and absorbed any energy or emitted energy, it is not a continuous one. It is a packet of energy. Its packet of energy is known as quanta, and in case of light, this packet of energy known as photon. And each packet of energy associated with some energy, and that energy is directly proportional to the frequency of the emitted radiation. And we can calculate that each packet contains energy E equals to h nu, where h is Planck constant. The total amount of energy of the radiation, total amount of energy of radiation E equals to, total E equals to n h nu, where n is integral multiple, n may be 1, 2, 3, etc. So each packet which energy consists of discontinuously it coming out, and this energy packet is coming by the emission, and